This is Just Tool Basics, and today we're talking about multimeters and some of the things they can do around the house. Hello everyone, welcome to Just Tool Basics. Today's topic is multimeters, and we'll talk about how they work, some of the basic things they do, and then give some examples of how to apply those features to some tasks around the house. Now, before we get into that, let's talk about what we call these things. I say multimeter. Plenty of people say multimeter, and then people who follow the weird pronunciation on Google or whatever say multimeter. No one in real life says multimeter. That's a weird way to say it. Multimeter, fine. If you're a little old school, VOM might be what you call it, which stands for voltage, ohms, and milliamps, which is back before they were digital, kind of all they could do. And when they combined individual tools, a voltmeter, an ohm meter, and a milliamp meter into a single tool, the VOM combination is what you had. And some people will say multi-tester, also not a completely unheard of term. If you're on a job site with electricians, they're just going to say meter, or occasionally they'll just say Fluke, which is the brand that these yellow and gray ones are, which is kind of the Kleenex of multimeters. Fluke is. Anyway, so basically, what multimeters do is they measure different characteristics of electricity. And then some of the nuances of how they measure it or some of the other advanced features vary from multimeter to multimeter. This one, pretty fundamental. Here we have AC volts. AC is alternating current, basically what comes out of the walls in your house. DC current, or direct current, think batteries, laptop chargers, things like that. Millivolts in DC, this solid line with dots underneath it is the sign for DC, whereas this little tilde sign is AC. This is beep mode, which this is where you're not looking to measure it per se, just verify that a wire or circuit isn't broken anywhere. This middle one is ohms, which is a measure of resistance. This is a capacitor measurer, less applicable to home stuff, so we're going to not go into that too deeply. Similar to this, diode directionality measurement. It just doesn't have too much application in the day-to-day needs of a home user, or maybe I'm just missing out entirely. I don't know. This is milliamps and amps. It applies on this meter to both DC and AC, and this is microamps, similarly DC and AC. Now, this has some advanced features up here that are enabled with these buttons. We are going to use this one, which is the beep mode. But for the most part, these are advanced features, and we're just going to go into the basics today, so I'm not going to get into that. When you turn this on, you can see that the display up here lights up and tells you what it's measuring. We'll show more of that later. Down here we have the terminals. You'll note that I only have two wires plugged in. It's because you only use two wires. This black one is plugged into COM, which is common ground. This right terminal is where you do most of your measurements. Here you can see that it's volts, ohms, and the diode symbol, which is basically everything on this side, which is everything except for the amp measurements. These are fused so that you can measure amps, up to 10 amps here and up to 400 milliamps here. And you can also go into the microamps for very small levels of current output. But by default, and unless you're really into measuring amps, you're only using the right side here. So that's the basics of this multimeter. Now, I also purchased at my local Harbor Freight their most economical offering today. This is it retails for $6.50, but I wasted my 20% coupon so that I got this guy for $5.19 before tax. And haven't opened it or tested it or anything. And so hopefully, there we go. It turns on. So this doesn't have an auto ranging feature. And what that means, turn that off for now, is see here it says DCV It just uses the letters instead of the little symbols. But it's not just one setting. You actually have to choose what your maximum expected voltage is. Now, all that does is kind of set up the math inside of its little brain. You're not going to hurt it if you set it to 20 volts and then measure 200 volts. It will just not display properly. It'll just give you an error, basically. But it's designed to take on all of these voltage ranges. You're basically just kind of choosing where the decimal point is, if you want to think of it that way. But similar to the Fluke, it measures DC volts. It measures the resistance, which you can then use as a continuity test as well. Here is the diode. Here's the capacitor function. Then DC amps here. As you can see, it only goes up to 200 milliamps. So it's definitely not designed for very much. This would be like for small electronics use. And then there is a 5 amp, as you can see, there's a little path to this terminal, ADC. And so this is only up to 5 amps. And there'll be a fuse in here somewhere. This one, on the other hand, goes up to 10 amps. I don't know that I would be comfortable shoving a full 5 amps through this little device. And then over here you see there's a little transistor tester. We're definitely not getting into that. That is definitely specific to electronics. I mean, you're not testing bare transistors on a day-to-day basis at your house. But yeah, lots of overlap between the two, and we'll do some comparisons to show that maybe not as fancy, but they basically do the same thing. So similarly, the terminals, you have your common ground, and then you have your everything except for amperage terminal. So we're going to get into some demos now, but before we get into that, let's have a quick chat about safety. We're going to be doing some measurements on current directly out of the walls of my house. So there are safety concerns that we want to take. So I'm not wearing any rings under my gloves. If I were a ring wearer, I would have taken them off already. I'm going to take off my watch so you can see my exciting watched hand line. And that's because on the off chance that something goes awry, we don't want to give a metal arc point where the electrical current can arc into and therefore introduce electricity into my body that I do not want. Besides that, I'm wearing glasses that are impact rated. I'm sure that there are folks who would want to take even more safety precautions, such as being on some sort of insulated mat. I'm in a carpeted room. I'm certainly not standing in bare feet on a wet concrete floor. I'm comfortable with taking basic precautions and moving forward. I'm not wearing insulated gloves. If your preference is to be fully OSHA compliant, this is probably not sufficient for your tastes, and that's fine. If you're not comfortable, you shouldn't do it, obviously. I'm comfortable with my level of safety here, but I'm not your safety inspector or your boss. So if you have any concerns, you should seek out the help of a professional who can take the appropriate safety precautions for their own interactions with electricity. Let's start with this guy. This is plugged into the wall and obviously is a power strip. These are, of course, the same as your wall sockets if you're in the United States or Canada or anywhere else that uses this style. The approach is similar, though, wherever you are. AC current is what's coming out of your walls. The first thing we're going to test is AC voltage. We do that by switching the selector knob to voltage on AC. Now you can see it's displaying a tiny amount of nonsense millivolts. It's normal. Once it gets a real signal, it will stabilize, but it does that sometimes. Now, when we're testing, what we're going to be doing is inserting the tips of these probes into the two blade sockets of the outlet. I'm going to be doing this one-handed. The reason for that is were something to happen, and I had it in either hand, and it arced through or off of one probe into my hands, it would then route through my heart, which I don't want. So we do it with one hand. That way, should something happen, it will just shock my hand, which may be unpleasant, but a lot more pleasant than it shocking my heart. Of course, I'm going to take care to not cross the probes while I'm inserting them. That would cause a short circuit, which also we don't want. Just some basic precautions and everything should go pretty reasonably fine. So now, as you can see, it's reading a pretty steady 119.3 volts. Now, I realize it's not 120 volts even. People generally refer to the electricity that comes out of our walls in America as 120 volt service, and that's true. However, even within the system, there is variances, voltage drops, things like that. As long as you're within a few percent, it's normal and it's fine. This tells us that this outlet is working, right? Like, just because it's 118.9, something must have turned on somewhere in the house, maybe, caused a bit of a voltage drop, or there was a fluctuation in the grid. Who knows? However, this does tell us that the outlet is working, of course. The sign that something is amiss would be if this read 80 volts or 160 volts. That would be bad. That's way out of spec. But if it's anywhere between like 115 and 125, I'm satisfied that my outlet is working as appropriate. And it's steady as well. Like it's not constantly fluctuating by 10 volts or something like that. Now, alternating current, of course, is alternating back and forth, positive and negative. If we switch the direction of the probes, like this, it doesn't care because it wouldn't make sense for it to care. It's alternating back and forth all the time. That's its job. Now, let's compare the output on this multimeter with our brand new Harbor Freight cheapie. So we'll turn it on. We'll set it to this range, which says 200 AC volts. Same process. Now this thing thinks that it's 117 point something. And that's fine. They're a little bit different, as you can see. I tend to trust what comes out of this machine more than what this machine's opinion is. But like I said, it's fine. If you're looking for hyper precision and you need this to validate some super important scientific machine, probably aren't going to be using this multimeter to start with. That said, we can't be positive this is right. Now, this is a calibrated Fluke 87, but it could have fallen out of calibration since its last calibration. Like, we would want to verify if we were going down that road of fussy precision. Now, as I mentioned, AC is what comes out of the walls, but once you get into chargers, batteries, things like that, DC is what you end up with. So here we have, and I chose this just because it's big, we have the power brick from the dock to my laptop. Now, this spec says, I'm not sure if you can see that on camera, but it says that its expected input is 100 to 240 volts, which means that they use the same body regardless of if you're in Japan, which is 100 volts, the North American area, which is 120 volts, or you're in Europe, which is 240, right? It doesn't really care. It normalizes whatever you put into it within a reasonable range of worldwide stuff, and then outputs 20 volts at 9 amps, right? So this is DC because it is doing an AC to DC conversion. So we need to switch our device to the 20. Now, this is supposed to output 20, so we're kind of in a weird spot since this is saying 20 or less, and this next option of 200 is saying between 20 and 200. So we'll choose 20. If it reads over limit, we'll make an adjustment. Now this does matter for the readout, which is positive and which is negative. Now, I'm assuming the barrel is negative. It's not always true. There's plenty of things that the barrel is positive. For example, guitar effects pedals. That's normal, as the barrel is positive. Who knows? My theory is someone wired it backwards and they just won't admit to it way back in the day. And now it's normal. So we're going to intentionally do this, what I presume is backwards. Now, you can see this -1 and blank means over limit. So this is putting out a little bit more than 20 volts. So we'll click this to the next setting. Yeah, 20.3. So because it's more than 20.0, it just comes up as an error. Now you'll notice that there's a big negative on the screen, and that negative is because I put the probes intentionally the wrong way around. That doesn't mean that I'm hurting anything or anything else. It just is telling you that it's telling you which one is the positive and which is the negative. So if we put it the correct way around, you can see it says 20.3, now 20.4, without the negative sign. So it tells us that for sure the barrel is the negative or ground, and the center is the positive. Now let's again compare to the other one. Also, you'll notice I'm using two hands now. The DC is so much lower output, so much less voltage that I'm being a little bit sloppy. And it's just hard to do this with one hand. Now this thinks, oops. Thinks that it's only 12 volts. Oh, because I'm on AC still. There we go. So it's only like reading half of it. There we go. So 20.4, come on. 20.4 or so. Again, this reads just a little bit higher than the Harbor Freight one. I don't know. Just how it is, I guess. So we're also going to measure amps. I can't measure amps with this because this is supposed to have 9 amp output, whereas this only goes up to 5. You do want to be careful with that because if you measure... I know. Is yelling at me because it was in the wrong mode. It knows when you put the probe into the wrong terminal, depending on your setting, and chirps at you to tell you to fix your stuff. Now, if this were an 11 amp thing, then I would not want to use this to test the amperage. I would need a device that's rated for higher amperage because it'll just pop the fuse, and then I have to take it apart and put in a new fuse, which then, I wasted $10 because these fuses aren't cheap. But let's test it. So I have it set to milliamp amp as opposed to microamp. Again, that wouldn't hurt it. Well, actually, I don't think it would work because it would be the wrong terminal. But this one is auto-adjusting for DC versus AC, as we mentioned before. Oh, see, it says it's over limit, so I think it's putting out a little bit more than the 9 amps that it claims, which this thing is a little bit self-protecting, and it was just flashing over limit, and if I kept holding it there, it would pop the fuse, which I don't want to do, as I mentioned. So we'll test that functionality on a battery. So let me put this away. And we'll grab this. This is a Makita battery out of my impactor. So first, let's show that the voltage test works similarly. So with this Makita, you can see that you get a little reflection in the light. You can see that there's little grabber things in these two slots. So that's where we test it from. Jam the things in there. And with this, it actually has a plus minus molded into it, which doesn't show up very well on camera, but there we go. You can see it there with the reflection on the light. And this is rated to 18 volts, and it shows 17.88. To be fair, I pulled it off of the impactor after having used it for unknown amount of time. And so, yeah, it probably is down to 17.88 volts because it uses it as you use it. So it's not freshly charged, so that's not a surprise. There's these, you can see there's like a little barb on there. It likes to get stuck and stuff like that. The Harbor Freight version has no such luxury of, well, it does have little barbs. All right, we're still set to 200, so I'll turn that down to 20. And there we go. So this more or less agrees, thinks it's 17.82 instead of 17.88, but good enough to get you in the right ballpark. So it gets the job done for this kind of simple stuff. Now let's, yikes. These probes pulled the wire out because the little barbs got stuck. Didn't hurt anything, they just popped back together. Let's jump back to, more standard batteries that you might encounter. I grabbed this D cell, which, always using the D cells these days. But these should be, actually we go down to 2000 millivolts. Other way around. There we go. Yeah, so 1568-ish millivolts, which is 1.5 volts. So if we turn it up to here, it'll just say 1.58. So like I said, this selector is basically just choosing where your decimal point is. Now back to this guy. And it agrees. 1.5, whatever. And like I mentioned before, this is auto ranging. It puts the decimal point where it thinks is the smartest, which it generally does a pretty good job of that. So I mentioned continuity. Let's move on to that. So simple continuity would be where you have a wire or some kind of circuit, and you just want to verify that end to end the circuit is complete, right? So for example, we'll take this probe as an example wire. Switch it to this mode, turn it just on beep mode. In general, once you set it to beep mode, you touch your probes together to make sure that beep mode works. And now I'm touching one probe to one end, and then I touch the other end, and it's beeping to just tell me that this is a contiguous wire. Now, testing that your wire is unbroken is kind of an edge case. I mean, you need it sometimes, but it's not an everyday thing. An application that this does make sense, though, is, for example, a while ago I had, this is from a UPS for computers, where the battery died. It was an older model. I needed to get rid of it. But the cable on it, it's really nice. It's heavier duty. This is looks like about 16 gauge wires. It has the nice angled plug. I didn't want to throw it away because I'm the kind of person that doesn't want to throw that kind of stuff away. But let's say that I wasn't sure which of these wires applied to which of these prongs. Continuity is an easy way to figure that out. So let's throw a probe on one side, make sure it's not touching another part, and then we know it's not green. Green goes to the ground lug. Is it the black one? Nope. It's the white one. So now we know that facing us, the right one is the white one. And of course, we wouldn't want to just presume that the other one is okay. So let's test that this one is the black one. And it is. Yeah. So this is a quick way to trace one end of a wire to the other. There are other ways to do that, of course. I'm sure that some of you out there are familiar with tracer probes and things like that. This is the less fancy way of doing it. You're just using continuity testing to determine A to B. Let's turn off that beep. Now you may have also noticed that while testing, the numbers go crazy a little bit. That's telling you how many ohms of resistance there are down the length of that wire. And it should be a very low number. A 10-foot chunk of copper shouldn't have terribly much resistance, but it does have some. So yeah. Almost forgot to retest the ammeter part of this. So let's switch to that. Get back to ye old Duracell battery. And as you can see, it's reading about 10 amps. And it drops because it's actually using up the energy of the battery as you hold it there. So it'll keep dropping. So you definitely don't want to test the ammeter functionality for a long period of time if you can help it. You're introducing this as a current draw on whatever your source is. So it will pull as much as it can, which, you know, isn't the best usage of your battery. So that's the basic functionality of both of these devices. As you can see, there's lots of overlap between them, but not entire overlap. Auto ranging is super nice. This one has transistor testing if you need that, but for the most part, they do what each other does. Some of the differences, though, besides that, with this one, you have, you know, this min-max feature, so you can turn that off and it kind of records over time. That way, if you can't be standing at it, like you're testing something on your car's motor and you need to be flipping the key around while this sits in the engine bay, then you can go back and look at it and see what your min and max values were, and that may be something you need to know. You may have noticed that this is labeled as a true RMS multimeter. RMS means root mean square. That is basically saying that it's applying math to non-sinusoidal waveforms. So you may know that in North America, our electricity is on a 60 hertz sine wave. But lots of things, especially things going through electronics and motor controllers and things like that, don't have that beautiful smooth wave. It's more like steps up and down, very, squared off. This still can measure those things, and it applies math to it to smooth it out and report that smoother version. Basically, taking that AC form, non-sinusoidal AC form, and calculating the equivalent direct current version of that measurement, which I know is a mouthful, but when you're talking about like a motor controller, like an electronic ballast for the old style tube fluorescent lights, some HVAC things doing motor controlling, things like that, it's not smooth. It's a very squared off, or it has these like weird little humps as opposed to a smooth sinusoidal wave. This does all that work for you. This one down here, you can see that it's rated Cat 3, which means that that's the rating that tells you how much voltage it's designed to handle safely. A Cat 3 are things like your main breaker box, some industrial applications where you're talking about larger voltages than the average household person would want to encounter. This is only rated to Cat 2, it says, which is good enough for, home outlets and things like that, but not higher voltage, not three-phase, things like that you would need at least this. And then there is Cat 4, which is like industrial level equipment that's designed for much, much larger electrical sources than I would be comfortable dealing with. I'm not trained for that sort of thing. Other differences between these two, as you can see, this one has an extra decimal point in its display. It has 1 plus 4 points. This one has 4 digits only, so it can go a little bit more precise. And this thing updates faster. You may have noticed that during some of those tests, it finds the number faster on this one, which may make a difference. Now, of course, all this fanciness has to be balanced against its cost. Now, this is an older version. This is an original Fluke 87. They're now up to 87 version 5, I think. And then they have another version of that, like the 87.5 Max, which is like drop rated in case you are clumsy and drop your stuff off ladders. But the new version of this costs about $400. The Max is another $100 or so. Like I said, this is older, so you could probably find one on eBay for, I don't know, 150, 200 bucks. They are warranted for, I think, forever still. So this is like, a pro tool. This is $5, as we mentioned earlier. So is this thing $395 better? Or let's even say we're getting it cheaply on eBay. Is it even $100 and some dollars better? I don't know. In some cases, yes. But for around the house, making sure my outlet works and it's not just a problem with my lamp, or making sure that my laptop isn't charging because the charger's broken versus the laptop is broken, I think the $5 version is fine. But if you're using it all the time, and certainly if you depend on it for your work and you want it to last and not break on you, an investment in a quality tool is better. Of course, this is a kind of the two extremes of what there is in the world. There are lovely multimeters out there that are in the $30, $40, $50 range that work great. They're, again, still not this level of quality, but, like I don't balance this on my running motor while I'm testing something either, because I don't want to damage my nice multimeter. I have a $50 one that's for balancing on motors in case it falls into the fan and gets exploded. Then it'd be a bummer, but it's not the end of the world. This would be upsetting if I did that to this. So, you need to evaluate your use case. I have one of these in the glove box of my old 67 truck. If something goes wrong on the side of the road, I need to do a quick evaluation. This is the thing I'm going to go for, because this goes in the glove box of a truck that I might as well not lock. Anyone with half a brain can break into my truck. So I'm not going to have an extra of these that I keep in my glove box or try and remember to bring it with me. That's just crazy talk. So this is exactly it. I think I actually own 3 or 4 of these, but I bought one just to show the out of the box, that it works fine. So I think that's about all we have for today. Until next time, this is Just Tool Basics.